Okay, good morning. We are going to start chapter 5 today. And so our first section is talking about fundamental identities. You're going to want that formula sheet that I gave you yesterday handy because we're going to be looking at it a lot. The identities we're focusing on today, some of these are on your handout and some are not because I expect you to know them at this point. The first ones, these are not on your handout, so you might need to jot them down. You can write it on the back. Just keep in mind that the formulas I give you on a test are the ones on that handout. So if I talk about something else here and it's not on the handout and you don't remember it, you want to write it down and then make sure that you know that when it comes time for the test. So these are just talking about reciprocals. We know tangent and cotangent reciprocals, sine and cosecant, cosine and secant, so that property still holds. We know that tangent is sine over cosine, cotangent is cosine over sine. So if you need to pause the video right now and write that down, you can. Pythagorean identities, these are on your formula sheet. We have talked about them before. We haven't used them a whole lot, but these are going to be very important today. The other thing, we talked about the negative angles when we were graphing. We talked about it in terms of even and odd. And remember, cosine and secant were the two even functions. They were the only two that if there was a negative on the angle, you could just drop it. The other four are odd, so if there's a negative on the angle, you need to pull it out in front. Okay, so then today I am just going to practice taking trig expressions and simplifying them. So we will use identities to rewrite the problems and then just simplify it to get a prettier expression at the end. I will probably do about 7 examples today, probably a few more than I would if we were in class, just to try to help you since you're kind of working on your own. So if you're getting it and you don't want to necessarily watch all of these, you can always go to the homework, and then if you get stuck, come back and watch the rest of the examples. So the first one I want to look at, if I give you 1 plus cotangent squared theta over... Incredible! Tell Celia hello. Hey Celia, go back downstairs with the boys, okay? Over 1 minus cosecant squared theta. I want to simplify this.
So I can draw.
Now we're going to see there are oftentimes multiple ways to do these problems. In other words, you have to show me work. Your answer on problems like this isn't necessarily just your final answer. It's the steps you take to get there. So more work is better. I can't give you credit for what's going on in your head. You have to write it down so I can see it. So if I were trying to do this problem, there are a couple different options. You might recognize, 1 plus cotangent squared is cosecant squared. 1 minus cosecant squared wasn't one of our identities, but you could get it from one. Keep in mind when I have identities like this isn't necessarily the only way you're going to see it. I could, if I have sine squared plus cosine squared equals 1, well, I could subtract over my sine and say cosine squared is 1 minus sine squared, or I could subtract over my cosine. And you could do that with the others as well. So there are several options for how to get your answer, and I don't care how you get there, you just have to show me. If you're stuck, the best option is usually just to change everything to sines and cosines. So since this is our first example anyway, that's what I'm going to do. Cotangent is cosine over sine. If it's cotangent squared, then it's just cosine squared over sine squared. If it's cotangent cubed, it becomes cosine cubed over sine cubed. Over 1 minus cosecant is 1 over sine. We are using techniques from algebra. There are a couple options again from here. You could try getting common denominator, but what I'm looking at here is I really hate having a fraction within a fraction. And if I want to get rid of that, all I have to do is multiply by my denominator. And as long as you do it on both the top and the bottom, that is legal. So I am going to multiply by sine squared theta on the top and the bottom of this fraction. So if I distribute, 1 times sine squared is sine squared. If I take cosine squared over sine squared times the sine squared, those sines drop and you just have a cosine squared. On the bottom, distribute and you get sine squared minus 1. Sine squared plus cosine squared, that's an identity. That is just equal to 1. So if you have an identity, you can replace it with what it's equal to. So I can change that to a 1. Sine squared minus 1. That wasn't straight from an identity. But we could get it if I took this identity and I subtracted over my 1, and then I brought over my cosine squared. Sine squared theta minus 1 is equal to a negative cosine squared.
Mom, can you take me bowling?
Alright, so we know 1 over cosine, the reciprocal of cosine is secant. Because it's squared, that's secant squared theta, and you have a negative in front. So my final answer, this thing simplifies into negative secant squared theta. So we're just trying to take a complicated looking expression and use our trig functions as well as algebra to simplify it into something nicer. Alright, so I am just going to practice a lot more of these today, and like I said, if you think you've got it, you can move on. If not, keep watching. So the next one I want to do So what I want to do here, if I don't recognize any identities immediately, I usually just change it into sines and cosines. I know secant is the reciprocal of cosine, so that's 1 over cosine theta. Plus, cosecant is 1 over sine theta. Times.
I'm allowed to set this at. Can we set it right here?
Okay. Now, we have everything in terms of sines and cosines. We're going to FOIL here. So I'm going to take 1 over cosine times cosine. When you do that, those cosines drop and just leave you with a 1. Outside, 1 over cosine times a negative sine. It's just like a sine over 1. So you multiply the tops of the fractions, you multiply the bottoms. So you get sine theta over cosine theta. Inside, this is like cosine theta over 1. So you multiply, you get cosine theta over sine theta. Last, multiply those, I get negative sine over sine, so negative 1. Positive 1 and negative 1 cancel. Sine over cosine is tangent. Cosine over sine is cotangent. So So I could leave it as negative tangent plus cotangent, or you could change it to cotangent theta minus tangent theta. Make sure when you have your trig functions, you're always writing an angle with them so that theta is needed. And you have to show me all of your work along the way so I know how you're getting your answers. Okay, let's try another. If I give you cosine x plus sine x over sine x. If it's cosine squared plus sine squared, I can turn that into a 1. But if it's just a plain cosine plus sine, I can't do anything. This is already in terms of sines and cosines. So the only option we really have, because there's only one term on the denominator, if you think about your algebra, you can do each thing divided by that term. So I can change this into cosine x over sine x plus sine x over sine x. Cosine over sine is cotangent. Sine over sine is 1. We have an identity if it's cotangent squared plus 1, but just for cotangent plus 1, there is no identity, so that is our final answer.
Well, this is really heavy.
Let's try. Okay. So if I look at this one, no identities immediately jump out, so I'm probably just going to go to sines and cosines. So you have to change quite a few things here. My cotangent, that is cosine over sine. Tangent is sine over cosine. Cosecant is 1 over sine. And then sine I'm just going to leave alone, but that is just the same as sine over 1. Okay, so now if we think about algebra, to divide fractions you flip and multiply. The numerator stays the same, times, and then I flip this bottom, so it becomes a cosine over sine. We have a 1 over sine, times, if I flip the bottom, that's 1 over sine. Okay, then to simplify, to multiply fractions, you multiply the tops and multiply the bottoms. So we have cosine squared x over sine squared x minus, if I multiply those, I have 1 over sine squared x. We know to add or subtract fractions we have to have a common denominator, but lucky for us, these do. So I can put them together into one fraction. That's cosine squared x minus 1 over sine squared x. Cosine squared x minus 1. If we took this, brought the 1 over, like we did here, but then subtracted over the sine, that would give us cosine squared theta minus 1. So this is equal to a negative sign. So negative sine squared x over sine squared x is just negative 1 for the final answer. I'm going to do about 3 more practice ones, and then that will be it for my examples. Again, if you've got it, that's up to you. If you want to start your homework, you may do so. Sine squared negative x plus tangent squared negative x plus cosine squared negative x. Okay, keep in mind when I say sine squared of negative x, that means you have the sine of negative x and then you square that. We know that sine is an odd function. That means the negative comes out. So it's negative sine of x squared. But when you square a negative, it just becomes positive. So sine squared of negative x is the same as sine squared x. Tangent is the exact same way. This is tangent of negative x squared. You know, if there's a negative, you can pull it out. But if I square a negative, that's positive. Cosine squared negative x. So that means you have cosine negative x squared. Cosine is even, so the negative just goes away. So this is just cosine squared. So we rewrote this without negatives because everything was squared. All those negatives just went away anyway. But now we have a sine squared plus a cosine squared. You can add in any order. So if I went ahead and added those two things together, sine squared plus cosine squared is 1. So I have 1 plus tangent squared. But we know tangent squared plus 1 is secant squared. So this is just secant squared x. Okay, this one has a couple different ways. If you recognize cosecant squared minus 1 is cotangent squared, so you could change that to sine squared x times cotangent squared x. Cotangent is cosine over sine. Sines cancel and you just get cosine squared. If you didn't recognize that identity, another way you could do this problem is to change cosecant to 1 over sine. Distribute sine squared times 1 over sine squared is 1 minus sine squared x. If you subtract that sine squared over, that is just cosine squared. So your work is what I'm grading on these, not just your final answer. Make sure you show me every step on how you're getting there. Couple different options. Last one. So this one is very similar to the first example that we did. The first example, we started out by changing everything to sines and cosines and simplifying. But I want to try this one differently. Tangent squared plus 1 is secant squared. Cotangent squared plus 1 is cosecant squared. I don't really know what to do from here, so now I'm going to go to sines and cosines. Secant is the reciprocal of cosine. Cosecant is the reciprocal of sine. To divide fractions, we flip and multiply. If you do that, you just get sine squared over cosine squared, which is tangent squared x. Okay, so today is just all about manipulating these formulas and trying to simplify things. I'm wanting you to get more familiar with the identities, recognize how to change things into sines and cosines, and go from there. I am posting a handout on Classroom for homework. I would like for you to try those. When you finish